Have you ever looked at something like the pyramids or the Parthenon and just wondered, how? How did they build these things with such perfect symmetry, centuries before we had computers or lasers? Well, today, we're going to unlock that ancient secret. And trust me, this isn't just some dry math lesson. It's a journey into the powerful, timeless art of geometric construction. Let's dive in. So, yeah, that really is the big question, isn't it? With no advanced tech, how did they pull off flawless circles, perfect right angles, and complex structures that have literally stood for thousands of years? You'd think the answer would be some lost, complicated secret, right? Well, it's surprisingly simple. You're looking at it. All of that architectural genius, all that precision, it all came down to just two humble tools: a straight edge for drawing straight lines and a compass for drawing arcs and circles. That's it. No, really, that's the whole toolkit. And with just these two things, you can build an entire universe of perfect shapes. Today, we're going to learn the basic moves.
Now, don't worry, you don't need to memorize hundreds of complicated tricks. It all comes down to just a handful of fundamental moves. Think of these as the absolute core of your geometric toolkit. They're the building blocks for everything else we're going to do.
So, our first big move is the art of bisecting. It's a fancy word, but all it means is cutting something, like an angle or a line, perfectly, and I mean perfectly, in half. This is a foundational skill, and you're about to see just how powerful it really is. So, how's it work? Okay, let's take any random angle. You plant your compass point right on the corner, and just swing an arc, so it crosses both lines. Now, from those two new points where the arc hit the lines, you're going to swing two more little arcs out in the middle so they cross each other. The last step, just draw a straight line from the original corner right through that new intersection point.
And boom, just like that. You didn't need a protractor, you didn't have to guess. That angle is now split into two absolutely equal parts. See? That's the magic of it.
So what about a line? It's pretty much the same idea. You start at one end, let's call it point B, and you draw an arc above and below the line. Now here's the key. Without changing the width of your compass at all, you move over to the other end, point C, and do the exact same thing. Then you just connect the two spots where your arcs cross over. Okay, now check this out, because this is where it gets really cool. When you do that, you don't just find the exact middle of the line. That new line you drew, it's also perfectly perpendicular, creating a flawless 90-degree angle. That's an awesome two-for-one deal, right? All right, so we've got the hang of cutting things in half, but what if we need to make brand new angles, right from scratch? Well, that's what we're doing next. We're going to forge some of the most important angles in all of geometry using just our simple tools. You are going to love how elegant this is. To make a perfect 60-degree angle, you start with a line. Put your compass on one end and swing a nice, big arc. Then, and this is the magic part, without changing the compass width, move the point to where that arc hit the line and swing another arc so it crosses the first one. Connect that crossing point back to where you started. And there you go, a perfect 60-degree angle. And the reason it works is just so cool. What you've really done is map out two sides of a perfect equilateral triangle. And if you remember your geometry, all the angles in an equilateral triangle are exactly 60 degrees. Pretty neat, huh? And we can use that same basic logic, swinging arcs that cross each other, to build a perfect 90-degree angle too. Yeah, it takes a few more arcs, like you see here, but the idea is exactly the same, using the compass to create these points that are an equal distance apart, which lets us to find that perfect corner. Okay, so this is where everything starts to click. We've made a 60-degree angle, we've made a 90-degree angle, so what if you need a 45-degree angle? Any ideas on how we could pull that off?
You got it. It's that simple. You just combine the skills you already have. You make a perfect 90-degree angle, and then you use that very first trick we learned. You just bisect it, cut it right in half.
And see? This is the beauty of this whole system. We build a 90-degree angle, then we chop it in half. 90 divided by 2 is 45. We're not just learning a bunch of random party tricks. We're building a toolkit where every skill builds on the last one. So now let's use that toolkit to build something a little more complex. All right, time to level up. We're going to take these basic skills, drawing lines, making angles, measuring with the compass, and put them all together to build a complex shape with very specific measurements. We're building a quadrilateral. So here's our blueprint. We've got 4 different side lengths, plus the length of a diagonal line that cuts across it. Now I know that looks like a complicated list of numbers, but we can build this shape perfectly just by following a few simple logical steps. And our compass is going to be our precision measuring tool. So we start by just drawing one side, maybe the base. Then we use our ruler and compass to measure out the exact lengths from our blueprint. From each end of that first line, we swing these big arcs. And you can see it right here. Where those arcs cross, that's exactly where the next corner has to be. You just repeat that process, and the shape just emerges, one corner at a time. It's kind of like a dance of intersecting circles. Okay, for our grand finale, we're putting everything, and I mean everything, we've learned together. We're not just going to build any old shape. We're going to build one of the most fundamental shapes there is, a perfect rectangle. So here's the challenge. We're given two side lengths, 5 centimeters and 3.5 centimeters. But we also know a critical fact about what makes a rectangle a rectangle. All 4 of its corners have to be perfect 90-degree angles. So how do we start? Well, first, we draw our base, the 5-centimeter line. And what do we need right away? A perfect corner. So we pull that 90-degree angle construction right out of our toolkit and build it at one end of the line. See? We're not just drawing what looks like a rectangle, we are building it from its fundamental geometric rules. Once that 90-degree corner is set, we just use our compass to measure and mark the 3.5 centimeter side. From there, it's just a matter of swinging a couple more arcs, using the lengths of the opposite sides to find that final corner. And just like that, we've combined every skill we learned, drawing lines, constructing angles, and measuring lengths to create one final perfect shape. So what's the big takeaway from all this? First, that incredibly simple tools can create absolute mathematical perfection. Second, that a few basic moves, like bisecting, are really powerful building blocks. And finally, that even the most complex-looking shapes are really just combinations of simple, repeatable steps. So, in just a few minutes, we've gone from cutting an angle in half to building a perfect rectangle from scratch. You now have the fundamental toolkit that architects and artists and engineers have been using for centuries. The only question left is, what are you going to create with it?